Hello everyone, it's Mrs Jennison here and I'm an Associate Director of Science for Outward Grange Academy's Trust. Welcome to our next lesson. This lesson will focus on the two homologous series, Carboxylic Acids and Esters. This is triple science only content. As with all of our lessons, it would be really useful if you had a pen and a piece of paper so that you could work through the activities with us throughout the video. Our challenge today is to be able to name and give the structures of the first four carboxylic acids and describe how they form. Our aspire is to be able to explain how the properties of carboxylic acids link to their uses. So to start us off, I'm going to insert a video here that's really good and goes through all the properties of carboxylic acids and how they form. If you wish to watch the original video, the link is displayed on the screen.
In this video, we're going to cover carboxylic acids. Just like alkanes and alcohols, carboxylic acids are a homologous series of organic compounds. But importantly, they have the functional group COOH, and their names all end in ethanoic acid. So this one, which has 3 carbons, is called propanoic acid. And in order, the other ones you need to know are methanoic acid, ethanoic acid, and finally butanoic acid. And one thing to remember is that when you write their formulas, you should always put the COOH group together at the end, like we have here. As you can probably tell from their names, these are all acids, and so they react like any other acid. However, they are all weak acids, so they don't fully ionize, which means that the carboxylic acid molecules don't all release their hydrogen ions. Because of this, we show their ionization with equations like this, with an equilibrium arrow between the full acid on the left and the ionized version where it lost its hydrogen on the right. The other thing to know is that these negative ions that they form when they ionize have names that end in anoate. So propanoic acid, like we have here, will ionize into a propanoate ion and a hydrogen ion. Like other acids, if we react a carboxylic acid with a metal carbonate, it will form a salt, water, and carbon dioxide. So if we reacted ethanoic acid with potassium carbonate, for example, it would form potassium ethanoate, which is the salt, water, and carbon dioxide. The last thing we need to cover is how carboxylic acids are made. It's actually pretty simple. All we do is take an alcohol, like butanol, and oxidize it using an oxidizing agent, which basically adds an oxygen. And we end up with a carboxylic acid, which in this case would be butanoic acid, because it still has 4 carbons, and so starts with but. Anyway, that's everything for this video. So, hope you found it useful. If you did, then do give us a like and subscribe, and we'll see you again soon.
So now that you've watched that video, I'm going to give you 2 minutes to answer the questions on the screen based on carboxylic acids and what you have learned from the video. Okay, so carboxylic acids form when an alcohol reacts with an oxidizing agent. You may remember from a previous topic that when a compound is oxidized, it gains oxygen. The functional group of carboxylic acids is COOH, and it must be written that way in the chemical formula. Carboxylic acid with 2 carbons would be called ethanoic acid. Its common name would be vinegar. And the pH of carboxylic acids is pH 3 to 5. They are weak acids, and the reason for that is that they only partially ionize, which means their compounds only partially dissociate into their hydrogen ions. And of course, it's hydrogen ions that cause a substance to become acidic. Now we name our carboxylic acids in the same way in which we named our alkanes. So we have the first part of the name, which indicates the number of carbons in the molecule. Meth, eth, prop and bute, again, with our little rhyme on there, just to remind you of the order. And then the second part of the name is the part that indicates that that molecule is a carboxylic acid. And these end in anoic acid. So we have methanoic acid, ethanoic acid, propanoic acid and butanoic acid. After that point we'd have pentanoic acid, hexanoic acid, etc. But you only really need to know the first 4. Now I'm going to insert a video of how to draw butanoic acid using those golden rules again. Again, we make sure that that functional group is on as soon as we have drawn our carbon chain and joined it up. So I'm just going to show you a video doing that, and then we'll ask you to have a go at a few. Now we're going to draw butanoic acid. Now, bute means that we have got 4 carbons, and anoic acid means that we have got a carboxylic acid, which means it will have the functional group COOH. Remember, these are formed when alcohols have been oxidized. So the OH will look like an alcohol group, but we will also have an added oxygen onto that carbon. So, as with all of our molecules, we're going to draw carbon first. Then we're going to join it into a chain. Then we will add the functional group. So we've got a double bond O, because oxygen forms 2 bonds, and an OH. Then all of our carbons need 4 bonds. This one already has 4 bonds. Then we've got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and we'll add our H's onto those bonds. Now, if I'm writing the formula, it's got to end in the COOH from this section here. So again, as I did with alcohols, I can name all of this, or I can split it into the sections of the molecule. So if I was using all of this, I'd have C3H7 COOH, or I could have CH3 CH2 CH2 COOH. I'm going to change that too because that's a little bit too big. Okay. So now that you've seen that video, I'd like you to have a go at drawing ethanoic acid, giving its chemical formula and circling the functional group, and then doing the same for methanoic acid. Okay, so you should have something that looks like this for ethanoic acid. 2 carbons, we've got the double bond O and then the OH coming off one of the carbons, and then 3 hydrogens coming off the other one. So the chemical formula will be CH3COOH. The functional group, you would actually include that carbon in the functional group as it is COOH, which is the functional group. So that's the section you would circle there. The methanoic acid, people get this one wrong, so be careful when you're drawing the 4 bonds around the carbon. That means the chemical formula would actually be HCOOH. And the functional group would be the section circled on the screen. So there is an experiment you could do that is linked to carboxylic acids, and it's one that they commonly ask about in exams, and it's about comparing carboxylic acids to strong acids such as hydrochloric. So the thing we would do is we would measure out a fixed volume of ethanoic acid or any other carboxylic acid and add a piece of magnesium into a beaker. If you then pour on the ethanoic acid into the beaker, you can record the observations you will see, and you will see fizzing. And then you can repeat that with hydrochloric acid and compare your observations that you would make. Now what you should see is something that looks like this. So on the left, I've got hydrochloric acid with magnesium, and you can see there's vigorous bubbling. It's definitely effervescent. And then if you look on the right, I've got ethanoic acid and magnesium, and you can see whilst it is bubbling, there's not as many. And that's an experiment we can use to indicate how even if these 2 acids are the same concentration, hydrochloric acid will be a stronger acid than ethanoic because it will fully dissociate into its ions. So even though the concentration of these acids is the same, we're getting a different result due to the nature of that molecule. So now that we've gone through that, I'd like you to use what we've just discussed to describe and then explain how the reactions with magnesium were different when ethanoic acid was used instead of hydrochloric acid. So we should have something like this. When ethanoic acid was used, there were fewer bubbles, which means the reaction is slower. This is because the ethanoic acid is weaker with a higher pH. And the reason that ethanoic acid is weaker with a higher pH is because it only partially ionises in water. Okay, so now that we've covered that section, I'm going to give you a little quiz again. I'm going to give you 2 minutes to just answer the questions on the screen that are just really key facts that we need to remember from this topic. So the carboxylic acid with 4 carbons is butanoic acid. The alcohol that would form propanoic acid would be propanol. The ion found in acidic substances is hydrogen. Propanoic acid is shown on the screen, and if you were circling the functional group, it is that green section there. Now, one of the reactions of carboxylic acids is that they can form esters. Esters have pleasant scents and are used for perfumes and flavourings. One of the most famous ones is pear drops. So if you think about that pear drop smell, that's caused by an ester. They can also be used as solvents. Now, esters are actually formed when carboxylic acids react with an alcohol. Now, unlike the other homologous series, you do not need to be able to name many of these. The only one that you actually need to name is ethyl ethanoate. Now, that is formed when ethanol reacts with ethanoic acid. Now, the reaction for the formation of this ester is on the screen. The 2 functional groups react with each other and form a water molecule. The rest of the molecule joins together to form this ethyl ethanoate molecule in the bottom left of the screen. Now, in this case, the functional group is not at the end like the rest of our molecules have been. It is actually in the middle, and it's joining those 2 carbon chains together. So now it's time to look at some exam questions on this topic. So the first one, I'm going to read through and then give you some time to do. Hydrochloric acid and ethanoic acid were reacted with magnesium metal to produce hydrogen gas. At the start, both of the acids were the same concentration and both pieces of magnesium were the same size. So that's giving us both of our control variables. They'd like you to give 2 observations which show that ethanoic acid is a weaker acid than hydrochloric acid. Okay, so our next question. Vinegar can be added to food. Vinegar is an aqueous solution of ethanoic acid. Ethanoic acid is a weak acid. Which ion is present in solutions of all acids? And what is the difference between the pH of a weak acid compared to the pH of a strong acid of the same concentration? Give a reason for your answer. Okay, so the mark scheme for question 1 is on the screen. If you are talking in terms of the ethanoic acid, you'd be talking about how there's less bubbles and therefore the magnesium will also disappear or dissolve more slowly. As it's also an exothermic reaction, you could say there'd be a lower temperature rise. For any of those points, you could have the converse for hydrochloric acid. So you could say that hydrochloric acid has got more bubbles and that the magnesium will dissolve more quickly. For the second question, the ion in all acids is hydrogen ions, and it has to be H plus or the word hydrogen. You can't just have H. That's not a hydrogen ion, that's a hydrogen atom. For the second part, the pH of a weak acid will be higher than the pH of a strong acid. You could have also again had the converse, and then the explanations points would be because the weak acid is only partially dissociated or partially ionised, so there's not as many hydrogen ions in that solution. So that's everything for me in this video, and I will see you soon.